The last section in Unit 4 is titled Properties. This lesson will help trying to apply the properties of operations, so we need to learn about identity, inverse, commutative, associative, and we've talked about distributive. So properties are statements that are true for any numbers, and a counterexample is an example that shows that a conjecture is not true. So if someone makes a statement and you can use an example to disprove their statement, then you have found a counterexample. A situation with a counterexample could be, everyone in my pre-algebra class is a boy. Well, there are several girls, and so each of those girls would be a counterexample. It would disprove that everyone in my pre-algebra class is a boy. When we simplify, we are performing all possible operations, and deductive reasoning is using facts, properties, or rules to reach valid conclusions. So we have several properties that you're going to write in your notes today. There are 5 in total, 2 on their own slides, and then the last 3 are in a chart together. So the commutative property, and make sure you say commute, like riding in a train or a bus, is a commute, not commune, like the community. It's commutative. This is the order in which numbers this states that the order in which numbers are added or multiplied does not change the sum or product. This basically is just a fancy way of saying you can multiply in any order. You can multiply in any order. And you can also add in any order. So in the 2 examples, we have a plus b would give you the same answer as b plus a. Also, a times b would give you the same answer as b times a. And you can see in the 2 examples, 6 plus 9 and 9 plus 6 both give 15. 4 times 7 and 7 times 4 both give 28. The associative property also deals with addition and multiplication. And it states that the order in which numbers are grouped when added or multiplied also does not change the sum or the product. So if you're multiplying or adding more than 2 numbers, you can group them. So for example, here in this second bullet point, a plus b is grouped together first. So order operation says we would add these 2 numbers together first and then add c. But on the right-hand side, we've grouped b and c together, and then we would add it to a. So this is stating that it doesn't matter which way you do it, you'll get the same answer. Same with multiplication, a times b then times c, or b times c then times a. And you can see in the 2 examples, 3 plus 6 plus 1, grouping the 3 and the 6 gives you 9 plus 1 or 10. But over on the right, grouping the 6 and the 1, 6 plus 1 is 7, 3 plus 7 is still 10. So you do get a true equation, true expression there. On the right-hand side, we did 5 times 9 times 2, that's 45 times 2, or 90. And on the right-hand side, 9 times 2 first is 18, 18 times 5 is also 90. And one thing with the associative property is typically you will see a set of parentheses, and that helps tip you off that we are dealing with the associative property. Then we have 3 number properties, and it's probably best if you just copy this chart into your notes. I know that it will take you a few minutes, but just pause the video and get it copied in, and then you can hit play when you're ready to listen to the explanations of the 3 identities. So the additive identity, think addition. So when 0 is added to any number, the sum is the number. And in the example way on the right, you see 5 plus 0 is 5, or 0 plus 5 is 5. The additive identity. So that's adding 0 to a number. The sum is that number. The multiplicative identity And when you hear identity, you think of what do I do to that number to still get the same answer? So when you're adding, if you add 0, you still get the same answer. But in multiplication, if you multiply times 1, so when any number is multiplied by 1, the product is that number. So 1 times a number is just itself. And in the examples, you can see 8 times 1 is 8, or 1 times 8 is 8. Then finally, you have the multiplicative property of 0. And you could probably tell me in your own words what this means, but basically if you multiply any number times 0, the product or the answer is 0. So 3 times 0 or 0 times 3. So you have the commutative property, which says you can multiply or add in any order. You have the associative property, which says you can group numbers in any order. Then you have the additive and multiplicative identities, that's adding 0 or multiplying by 1. Then you also have the multiplicative property of 0. And I think next we're going to look at some examples. Oh, we're going to talk about conjectures first. So state whether the conjecture is true. If not, give a counterexample. So it says that the division of whole numbers is associative. Remember that associative means you can group things any way you like. So if we're going to divide with the associative property, let's group, let's do 12 divided by 2, and then we'll divide that by 3. 12 divided by 2 is 6. 6 divided by 3 is 2. Now if I regroup, and I group the 2 and the 3 together instead, I'm trying to determine, does that equal 12 divided by 2 divided by 3? Well, 2 divided by 3 is 2/3. So we have 12 divided by 2/3. Dividing by a fraction is the same as multiplying by the reciprocal. So 12 times 3, this is 36 over 2, or 18. So you get 2 on the left, you get 18 on the right. Those are not equal, so here's the counter example using the numbers 12, 2, and 3. And you actually could have picked any numbers besides all ones, but the associative property does not apply to division. In division, with division, order matters. Now let's see if it's commutative. And this one hopefully is pretty obvious. Commutative means I can divide in any order. So is 12 divided by 2 the same as 2 divided by 12? And you know in a calculator, when you're looking at fractions and you're trying to reduce fractions or simplify them, you know that the numerator has to be divided by the denominator. We can't go the other way. So on the left we get 6, on the right we get 1/6. Those are definitely not equal. So the division is not commutative either. Division, when you're dividing, order matters. So let's just name the properties shown. For the first example, we have 3 times 10 times 2, or 2 times 10 times 3. So here we have multiplication where we're changing the order in which we multiply. So this is the commutative property. Number 4, we see parentheses, so that should tip us off, but we have 2 plus 5 grouped together, then we're adding it to m. Or we have 5 plus m that we're adding back to 2. This is the associative property. This is the one that tells us we can group addition in any order we like. Number 5, you see multiplication, and you see multiplication 1 times a number. So here 1 times 3c gives you 3c. This is the multiplicative identity. Remember, when a number times something gives you itself, or a number plus 0 gives you itself, those are identities. you'd like to pause the video and try the next three. Oh no, these are just simplifications. So this should be something we're pretty good at because we've done some work with combining like terms. So simplify each expression. When we do order of operations, we can't add 3 plus e because those are not like terms. However, if we regroup things, if we regroup the 3 and the 7 first and then add e, we know we get 10 plus e, and that this would be an equivalent expression. We've just grouped things differently. Here we have 8 times x times 5, so we could regroup here, or, I mean, you don't even really have to. You can do 8 times 5x, and 8 times 5x is 40x. On number 8, we would probably want to group the 10 and the 18 together. Those are the like terms. And we'll add the p on to the back. So 28 plus p. That's simplifying the expression by regrouping using our properties and our identities. So it's the commutative property that allows you to rearrange and the associative property that lets you regroup. In class, we will work on worksheet 4.9.